So coding is used if we have complicated data and we want to make it easier to work with. Okay, so for example, let's say that we had this data set up here and we wanted to find the mean and the standard deviation. Okay, now these are quite big numbers and they can be quite difficult to work with to find the mean and the standard deviation. So instead, let's use coding. Okay, so let's use the coding y is equal to x minus 600 over 6. So what this means is all of these data points here, we're going to sub them in as x, and then we're going to take away 600 and divide by 6 to get the new data, which is this here. Okay, so 630 becomes 5 and 636 becomes 6. And this data here is a lot easier to work with. And with this data, we can more easily calculate stuff like the mean and the standard deviation. And then using these values and using this code here, we can convert it back and find the mean and standard deviation for the original data. We'll talk about how to convert this back in a moment. So rather than calculating the mean and the standard deviation directly from this data here, we can use coding to simplify the problem and make it easier to find these values. Okay, now you don't really see this at A level, but coding can be really useful if you have massive data sets. So here we've only got 5 data points, but you could have, for example, like thousands of data points, and coding makes the data a lot more manageable. Okay, so you need to know how the mean and standard deviation are affected by coding. Okay, so let's say we have some data, which is x, and let's use the coding y is equal to x minus a over b. So all of the data values, we're going to subtract a and divide them by b. Okay, so the mean is going to be affected by both a and b. Okay, we're going to subtract a from it and divide it by b. But the standard deviation is only affected by b. It is not affected by a here. Okay, so let's go through an example. Let's say that we have this data set here. For this data set, the mean is 106 and the standard deviation is 2.83. Okay, and let's use the coding y is equal to x minus 100. So the new coded data set will be this here. Okay, now we can see that the mean has gone down by 100 with this new data set here, but the standard deviation is still the exact same. It's not affected by this value here, and this makes sense if you look at the data, because you can see this data and this data, the position has changed, but the spread of the data is still the same, so the standard deviation is still the same. So here's another example. I've used the same data set here, but I've used different coding. Y is equal to x over 2 to give this coded data set here. And we can see that the mean has been divided by 2, but this time the standard deviation has also been divided by 2 as well. And you can kind of see this in the data compared to this one, is kind of the data has been squeezed by a factor of 2. So therefore the standard deviation has also been divided by 2. A lot of the time you'll want to go the other way. So we've talked about here the perspective of going from the non-coded data to the coded data, whereas as we talked about at the start, a lot of the time we'll want to go from these values to these values here, and for this you just rearrange this formula here. We'll go for an example in a moment. Just another note that I want to make, we talk about the mean and the standard deviation here. I have seen one exam question where they have also asked about the median, as we'll go through at the end of this video. This coding works the exact same as the mean. Okay, so here's an example question where we're told that some data x has been coded using the formula y is equal to x minus 20 over 5. And for the coded data, the mean is 10 and the standard deviation is 2. And we need to find the mean and standard deviation for the original data. So this is where we need to go the other way around. We're given the data, or the mean and the standard deviation for the coded data, and we need to find the mean and standard deviation for the original data. Okay, so let's start with the mean. So we're told that the mean is 10 for the coded data. So remember, the mean will be affected by both the 20 and the 5. So therefore the mean of the coded data, which is this here, is going to be the mean of the non-coded data minus 20 over 5. Now we know the mean of the coded data is 10, so this is this y bar here, so y bar is equal to 10. So if we sub this in, this is going to be 10 is equal to x minus 20 over 5, then we rearrange in order to find x. So if we multiply both sides by 5 here, so this is going to be 50 is equal to x bar minus 20, and then move this 20 to the other side to get that 70 is equal to x bar. So this here is the mean for the original data. Now if we look at the standard deviation, so the standard deviation is 2 for the coded data. Now remember, the standard deviation is only going to be affected by this 5 here. So the standard deviation for y is equal to the standard deviation of x divided by 5, like this here. We know the standard deviation for the coded data is 2, so if we sub this in, it's going to be 2 is equal to the standard deviation of x over 5, so multiply both sides by 5, so we get that 10 is equal to the standard deviation of x. So this is the standard deviation for the original data. Okay, so here's another example where we're told some data x has been coded using the formula y is equal to x minus 50, and for the coded data the mean is 4 and the standard deviation is 6, and we need to find the mean and the standard deviation for x, which is the original data. Okay, so let's start with the mean. So we're told that the mean for the coded data is 4, so we've got this formula here. So remember, it's the mean, so it's going to be affected by this minus 50 here, so it's going to be y bar is equal to x bar minus 50. We know that y bar is equal to 4, so if we sub this in, it's going to be 4 is equal to x bar minus 50. Move the 50 to the other side, so we get that x bar is equal to 54, and this is the mean for the non-coded data. Now we need to find the standard deviation. Now the formula, the coded formula, is y is equal to x minus 50. Now remember, the standard deviation is not affected by any values that you take away or add. It's not affected by a, as we talked about before. It's only affected by b, which is if you divide by something, and we don't have this here. So therefore this standard deviation here is going to be the same for the non-coded data, so it's going to be 6. It's not affected by this formula here. Okay, so here's another question where we're told some data x has been coded using the formula y is equal to x minus 2 over 7. And for the coded data, sigma y is equal to 51 and sigma y squared is equal to 497. And given that there are 100 data points, we need to find the standard deviation for the original non-coded data. Okay, so to do this first, we need to find the standard deviation for the coded data, which we can do using this information here. Now go back to the standard deviation video if you need a reminder of how we calculate it. So the formula for the variance is equal to sigma y squared over n minus sigma y over n squared. Okay, so therefore the variance is equal to sigma y squared. We're told that sigma y squared is 497 over n, which is the number of data points, and we've told that there are 100 data points, so n is 100, and then minus sigma y, which is 51 over n, which is 100, and then this squared. And if you put this into your calculator, this is equal to 4.7099. So the standard deviation is the square root of the variance, so the square root of 4.7099, which if you put it into your calculator is equal to 2.17 to 2 decimal places. So this here is the standard deviation for the coded data, so the standard deviation of y. So we need to find the standard deviation for the non-coded data, so we need to find sigma x. Now remember, the standard deviation is only affected by this 7 here, so the standard deviation for y is equal to the standard deviation for x divided by 7. We know the standard deviation for y is 2.17, so it's going to be 2.17 is equal to the standard deviation of x divided by 7, and then multiply both sides by 7, so we get that sigma x is equal to 15.19, and this is the standard deviation for the original data. Okay, so here's one final example question for you to have a go at. Have a go at part C. Part A and part B we covered in previous videos, and I've given you the answers here because you'll need them for part C. So pause the video, have a go, and I'll go for the answer in about 5 seconds. Okay, so for this question, we're told a company manager is investigating the time taken in T minutes to complete an aptitude test, and the human resources manager produced the table below of coded times X minutes for a random sample of 30 applicants. And this is the grouped frequency table here. You don't really need this for part C. For part A, we estimated the median of the coded times, and for part B, we estimated the standard deviation of the coded times. And then we're told the company manager is told by the human resources manager that he's subtracted 15 from each of the times and then divided by 2 to calculate the coded times. And for part C, we need to calculate an estimate for the median and the standard deviation of T. So for part A, we estimated the median for the coded times. For part B, we estimated the standard deviation of the coded times. Now we need to estimate them for the non-coded times. Okay, so if we look at this coding, we're told he's subtracted 15 from each of the times and then divided by 2. So that means that y is equal to x, and then he subtracted 15 from each of the times, and then he divided by 2. So this is the code here. Okay, now technically actually that we're told the coded times are x, so technically this y should be x, and we're told the non-coded times are t, so technically this x should be a t, but it doesn't matter that much. Okay, so let's start with the median. As I talked about in this video, the median is affected in the same way as the mean is. Okay, so we are told that for the coded times, we know that the median is 9, or in other words, we know that y bar is equal to 9. Now remember, the mean and median are affected by both 2 and 15, so y bar is equal to x bar minus 15 over 2, and y bar is 9, so 9 is equal to x bar minus 15 over 2. Multiply both sides by 2, so we get 18 is equal to x bar minus 15, then add 15 to both sides, so 33 is equal to x bar. Okay, so now if we focus on the standard deviations, so we know that for the coded times, the standard deviation is this here, or in other words, sigma y is equal to 7.01. Now remember, the standard deviation is only affected by this 2 here, so sigma y is equal to sigma x divided by 2. We know sigma y is 7.01, so this is equal to sigma x divided by 2, and then multiply both sides by 2, so we get that sigma x is equal to 14.02, and this is the standard deviation for the non-coded data. So this is the mean, and this is the standard deviation.